Welcome my dear students. Welcome to our channel Kcyc. Today we are going to start with a new chapter in your paper 1, Laws of Motion. Before starting with laws of motion, I would like to discuss something which is very basic and you must have learned in your previous classes also. They are displacement and distance. As you know, displacement is a minimum distance between the starting and the finishing point. It is not required should be start, should be finish. Like for example, if you're moving from one A to B, there should be a minimum distance. That is the shortest distance, so that one can travel from point A to B. Whereas in distance is a length of actual path traveled by an object in motion while going from one point to another point. So displacement is a minimum distance, shortest path, and distance is the length of actual path. In the figure, you will be able to understand how it works on. See, here you can see a displacement which will be the shortest path. Distance can be anyhow. It's a individual decision, or it's a particular decision which we should consider as distant. But displacement should be mandatorily the shortest path. See the black one again, this is another, this is distance or displacement. Absolutely, this is distance. You can travel by any path. One more I'll show you. Yeah, this yellow line also, this is again a displacement or distance. Which is that? Yes, exactly, you're correct. It is again, it's a distance. The displacement remain exactly at the shortest path, that is the shortest position from A to B. So here is the formula for distance and displacement. Distance, generally speed is equal to distance upon time, where displacement, it's mainly depend upon the velocity. Velocity is nothing but again this is a displacement by time. Here distance by time. Distance by time you will get speed. Displacement by time you will get velocity. This is a general formula for it. The next part of the chapter deals with uniform and non-uniform linear motion. Whenever you say uniform linear motion, it means there should be a consistency in the linear motion. How we can understand whether it is a consistent motion? We can take a help of time over here. So after a particular interval, what is the speed of a particular object moving? In this case, you will be able to find out in page number 4 of your textbook the example of 3 people traveling in different cars with different velocities. Let us consider Amar, who is traveling with respect to this velocity, that is 0-20. That is every half an hour. That you can able to understand that there is 30 minutes difference in between. 5 to 5:30 he traveled in 20 kilometers. Next 5:30 to 6 he traveled again the next 20 kilometers. So it was consistent. Here also you will able to understand Anthony was also consistent with respect to the distance kept by him, even though speed differs. You will able to understand, because here within half an hour he covered within half an hour he covered 20 kilometers. Here he covered 14 kilometers. So you will understand the velocity in case of Amar is higher with respect to Anthony. But I would like to put a focus on over here with respect to Akbar, where you will able to find an uniform acceleration over here. Then it suddenly drops off. There here you will have to understand this is a non-uniform linear motion. So page number 4 is there. There are questions with respect to this exercise in your textbook. Kindly try to solve it. Okay. So when a motion is in uniform means when it is consistent, that is, it is constant. It will just complete particular distance at a particular time interval. We can call it a uniform linear motion. There won't be an increase in acceleration or decrease in acceleration, or the entire movement will be stable, consistent, linear. Next part we are dealing with acceleration, where you will understand what is acceleration. Acceleration nothing but rate of change of velocity is acceleration. Velocity, change of velocity. How will you understand the way velocity is changing? That is change in velocity with respect to time. This is a general formula for acceleration. Look at the figure over here. You will able to see acceleration, where A is acceleration, T is time, and this is change in velocity. So the formula which I showed in the previous slide, you'll able to understand acceleration is nothing but change in velocity with respect to time. Here you got the formula where A will be acceleration, V minus U by T, where U will be initial velocity minus final velocity, where final velocity minus initial velocity will get T. Final velocity minus initial velocity is nothing but change in velocity. So students, you have to understand acceleration will is change in velocity with respect to time. You will get velocity, that is final velocity minus initial velocity. For example, a car is moving at 30 kilometer per hour starting. Okay, then it covered a distance, then it increases acceleration by 60 kilometer per hour. So what will be the change in velocity? That is 60. That is the final velocity minus the initial velocity. 60 minus 30, that is 30 kilometer per hour was the initial velocity. Okay, here generally in SI term we will always consider meter per second, not kilometer per hour. Just for a basic understanding, I told you it is just kilometer per hour. So change in velocity with respect to time will get acceleration. So there are two types of acceleration which you have to understand. This positive and negative acceleration. Positive acceleration is nothing but when velocity of an object increases, the acceleration is positive. In this case, the acceleration will be in the direction of velocity. So like for example, if you're traveling in a car, you just you just pressed your accelerator, ultimately the acceleration was happening. So 20 kilometer per hour, it went to 60 kilometer per hour, 40 kilometer per hour. So when there is an increase, we call this as a positive acceleration. Vice versa, when there is a decrease in acceleration, we call this negative acceleration. It's also known as deceleration, we call it. It is also known as deceleration. Clear, all of you? So students, next part is something very much interesting with respect to graph. Here we will be able to understand how we are converting the distance and time graph into uniform motion. If you look at the data over here, you will understand time is given one column 0, 10, 20, 30 in a consistent way. The distance is also given into 0, 15, that is 15 meters as distance, then 30, 45, 16, so on. So let us just plot the graph as of now. It is not plotted in your textbook. I am just plotting it for you so that you can understand it later on. You can draw it in your notebook and you can practice. So here at 10th second you'll get 15. At 10th second you'll get at 15, somewhere over here. Then you'll get 20, 28th second you'll get a 30 meter distance. So on. It is consistent. At every 10 second it is they are covering 15 meters. So when you draw the graph, it will almost look like this. Okay, it will just almost look that it's a straight and linear graph. Okay, so the distance and time graph of this is a uniform motion. So next is a distance time graph for a non-uniform motion. So when you look at the graph over here, you can see time in seconds, that is 0, 5, 10, 15, 20, 25, 30 and 35. And here it is 0, 7, 12, 20, 30, 40. So here you're able to see that it is not consistent. So even if you draw a graph like this, the time with respect to distance, it will go in zigzag, or it is not a consistent. It won't be a linear graph like this. So that is distance time graph. You can draw it. Now velocity time graph for uniform velocity time graph or uniform velocity, where you will see that the velocity will remain uniform. You can check in page number 6 of your textbook. You'll be able to find out this same graph over here. Okay, so with this we will able to understand that here we have got velocity, train moving with uniform velocity 60 km per hour for 5 hours. The velocity time graph of this uniform motion is shown in this figure. So you'll be able to see this is the figure. We will see A and B, that is A is the position and B is the final position. Here we will be able to understand it's a velocity time graph for a uniform motion of a train. The next graph is velocity diagram for uniform acceleration. So we have done generally with the velocity time graph of uniform velocity and time. Velocity graph for uniform acceleration is now what we have to going to do. Look at carefully. The acceleration we have to understand, this is velocity, and the change in velocity of a car in specific time interval is given in the table. Look at carefully the table. The time will be 0, 5, 10, 15, 20, 25, 30 and 35. Velocity will be 0, 8, 16, 24. So with the values you will be able to understand it is a very much consistent linear graph. You can see over here that is at the 5th second it is covering, the speed will be, the velocity will be 8. At the 10th second the velocity was increased to 16 meter per second. At almost around about 20, that is the 20th second, it was about 32. So with respect to this graph you will be able to understand the time velocity graph of a uniform acceleration. So students, we're going to the next part of the explanation of this equation, which is actually a relation between velocity and time. So there is a relation between velocity, time and acceleration. So in together they form a kinematical equation for motion, which I will be discussing when we complete all the relation. So first and foremost we are going with the relation between velocity and time. In order to understand, you have to note some you have to understand some geometrical part for the same thing also. So here we are using mathematics as a tool to describing the relation between velocity and time. If you look at the figure over here, and there is a velocity and a time graph, and this is the line for it, and these dotted lines are constructions. Later on we will be able to understand as we proceed further with the explanation. So here this is a velocity and a time graph, where as initial velocity of the object is u, the final velocity of the object is v. The initial velocity is represented by OD. U is represented by OD. If you know the previous slide which we have learned, I already told you u will be considered as initial velocity and v will be considered as final velocity. So here the u, geometrically it is OD, and the final velocity which is represented by v will be equal to OC. Look at the graph. As I say, you just go through the graph also. So the time is represented by t and it's again represented OE. Where is OE over here? It's OE. So this is OE. So it's happening in between O to E. At time it is having an initial velocity, then a final velocity. So acceleration, as you know, change in velocity with respect to time. Final velocity minus initial velocity will get the change in velocity with respect to time. Here with respect to this figure, final velocity is represented by OC minus OD upon T. Therefore the CD, what is CD? What will you get it? OC. OC minus OD, you'll get CD. Geometrically is absolutely correct. But CD is 80. How it is 80? I'll tell you how it is 80. OC minus OD is equal to CD. So here the 80 is nothing but acceleration with respect to time, because CD, the T will come over here. The T will come over here, there will be 80. So we are just further construction we are doing. We are drawing parallel lines at y-axis passing through B. At y-axis passing through B. This will cross x-axis at E. So it is making this cross over here. It is making a cross over here. Now there is also one more construction which is happening over here. Look at this. So draw a line parallel to x-axis passing through D. This will be O crossing the line BE at A. For the graph we will be able to find out BE equal to, look at this figure, BE will be nothing but AB plus AE. AB plus AE. Now V is equal to CD plus OD. How did you got it? V is equal to CD plus OD. Because CD is equal to AB. V, that is the final velocity, will be CD plus OD. CD plus OD. As you know, final velocity is also given by OC. So OC is comprising of two lines. This is OD and CD. So since OD and CD, it is also equal to this. Therefore, the CD is equal to AB and AE is equal to OD. So you're just substituting this value over here. So CD is given by 80 from this equation number 1, and OD is nothing but U. So this from the graph BE is nothing but again a velocity. Total final velocity will be given by V equal to 80 plus U. So ultimately we can find out V equal to U plus 80. This is the first equation of motion. We call this kinematical equation. V equal to U plus 80. That will be the relation between velocity and time. Very carefully just trace this figure and you will be able to understand. So next here we are dealing with equation describing relation between displacement and time. When you just carefully, I'm just putting this figure and again so that you will be able to understand. Nothing the same figure, we have already explained it. Now this will be much more easy because the first part, that is relation between velocity and time, we have already explained it. Just go through it one more time. If you just pause this video and just check it one more time so that you can understand it better. Once you are very much clear with that, then you can follow with this next equation, that is relation between displacement and time. So here again with the help of geometry we are finding on one more equation, that is second kinematical equation we call it, of motion. So let us move on to that. So here we have got a quadrangle over here, quadrangle, okay, quadrangle over here with the name D O E B. Look at very carefully, it is D O E B. It is not EA, it is EB. So this will be, it's a trapezium type of quadrangle. So it comprises of this entire figure comprises of two figures, that is one will be a rectangle, that is DOEA, plus a triangle which name is DAB. So the area will be given by this. From the figure you will find out the area, that is the total area S, we call it as, is area of a quadrangle. Area of quadrangle again split it into area of rectangle plus area of triangle. Here the area of rectangle is given by, that is area of rectangle DOEA is given by AE into OA, that is length into breadth. Everybody know this. This half into base into height is for the triangle, that is half will be half, base will be this AD or DA, and the height will be AB. So with this we'll get this. We also understand from the previous part of this explanation, AE is nothing but U, that is the initial velocity, and OE is nothing but the time. OE equal to DA again. Okay, since they are geometrically equal, O equal to DA, therefore D is again equal to T. AB, where AB is also known as AT from the previous equation, that is equation number 1, we got it. So AB is equal to CD. So CD is 80, therefore AB will also be 80. Therefore just simply substituting the value over here, you'll get U into T half. This will go over here, T square. Ultimately you will get the Newton's second equation in motion is equal to UT plus half AT square. Very carefully you just understand this. Okay, that is the second kinematical equation, that is the equation relation between displacement and time. So the next and the final kinematical equation is a relation between displacement and velocity. So as of now we have completed the relation between velocity and time, displacement and time. Now it is displacement and velocity. Very carefully look into the figure. I am just putting this figure and again so that it will be much easier for you to understand. So here we have got a trapezium DOEB as in the previous cases. So now we have to find out area of a trapezium. Area of a trapezium formula is half into sum of length of parallel sides into distance between the parallel sides. So half is equal to OD plus BE into OE. So here sum of the parallel side, that is nothing but OD plus BE. OD plus BE. parallel sides. That will be the sum of the length of the parallel side. And distance between two parallel sides. Distance between easily will be able to understand. Distance between two parallel sides. We've got two parallel sides over here. That is nothing but OD and BE. The distance between is given by OE, which is time. So sum of length of parallel sides. Sum of length of parallel side. We've got two parallel sides over here. That is OD plus BE, and that is multiplied by the distance between the parallel side. That is OE. Very carefully understood. Now the next part is OD is equal to U. OD is equal to U because it is a initial velocity, and BE is equal to V BE. Since OC is equal to final velocity, B will be equal to final velocity. OE is equal to T. So just substituting these values, you will get the value over here. But acceleration given by final velocity minus initial velocity will get acceleration. Upon T will get acceleration. So acceleration is final velocity minus initial velocity upon time will get acceleration. So just substituting the value over here carefully, you understood T equal to U minus V upon A. S equal to half U plus V as it is. Here we are substituting the value of T. T will be equal to V minus U upon A. We're just substituting the value over here. Arithmetic calculations which is happening over here, to AS will go over here. V plus U, V minus U is equal to V square minus U square. Ultimately, V square is equal to U square plus 2AS. That is the Newton's equation of motion. That is the third equation, third kinematical equation for motion. So we here have three equations which we already learned. V is equal to U plus AT. This is the relation between velocity and time. S equal to UT plus half AT square. This is the relation between displacement and time. The third and a final kinematical equation, V square is equal to U square plus 2AS. This is the relation between displacement and velocity. These three equations are very much important in order to learn the equation of motion or laws of motion. Okay, that's all for today. I'm just concluding the lecture. The next part will be taken next class. I'll also give you assignments. Kindly complete the assignment and submit it. That's all. Thank you.